you guys all might want to switch to speaker view if you see that in the top panel to make my screen bigger. And that way you might be able to see this a little bit better. And this is definitely, you know, Rachel Ray cooking show style. So I have things kind of prepped in different ways because it would take a while to do the whole thing. And so we're going to do the wax lava flow demonstration first, and please yell at me if I'm talking too fast, which is the first assignment, and it's on like page 48 in your book. And the required gear you need is we're still doing hot plates with wax. We're gonna build a volcano. And part of this is to talk about how volcanoes are formed and then look at different types of lava flowing in real life. But then also kind of understanding that, you know, when we do geologic mapping and we look at the Earth's surface, we're missing a lot of information. And so the clear wax is representing the missing stuff that we don't know. It's buried too far down, and unless we drill to go and see it, we got to infer from other information, geodetic data, seismicity, etc. But for this, really all you need is, you know, the bowl. I have some golf wax, which is the base of our volcano. I've actually melted a bunch of it already, so, you know, pull this down closer. So this is already some melted golf wax. And so what you'll need to do is early on is actually make your volcanic edifice. And so we'll take this melted golf wax and just pour it into the bowl. So I'm just going to lean it down. So there's wax in there, and that wax is just going to sit and cool. And the paraffin wax for the golf wax takes a long time to cool. It is much more fluid than the crayons. And so this morning, since I forgot to do that last night, I actually just carved my own little volcano out of paraffin wax. Not recommended for students because you have to use a knife. But basically what will happen is once that cools, you'll have this nice, flat, low-flowing edifice, which is way better than this is a little bit tall. Yes, ma'am. Oh, okay. So, and then I carved a hole in the center to represent the crater itself. And I find that it is easier to, because you're going to use the same beaker or container the whole time, using colors that will overlap onto each other better. So, you know, colors that you're going to just melt slowly at a time and create this volcano itself. So I break up the crayons because they'll melt a little bit faster, and that might take a moment. Crank that up a little bit. And what we're going to do is we'll melt one layer at a time, like we're building a volcano as it's erupting. There's always this repose interval, and like Sherry showed in that geologic map of the Valles, the Jemez Mountains, you know, every flow represents, or every color represents a different unit. And so we're just going to kind of build from the bottom up. And if you want to think about which type of volcano we're building right now, it's more like Mount Taylor than the Valles. So we're just going to be producing a lot of different lava flows and hopefully melting some wax. In the meantime, so that might take a moment. And one thing to think about, and this is in your book on page, well, the next page, where it actually shows the different types of lava flows. And that is pure paraffin wax that is purple in color because it was dyed with a previous version of a volcano I made, pure crayon, and then a mixture of the two. And so you can start to mix and match some of these a little bit to change the composition. And so these lava flows will change in how they flow and their shape, and based off of temperature, crystal content, and what minerals are in there. So if you have more stuff in the material itself, it'll be more resistant to flow. And then just the overall composition. So basalt's going to move way faster than a rhyolite would. Basalt temperature is somewhere around 1200 degrees C. A rhyolite can be 800 to 600 degrees C, and so that will also change your flow. So I'm starting to get some melt finally on my crayon, and we'll tip this guy down. So here's my little volcanic edifice. I've almost got lava ready to melt. And what we can do is just have and I like to put it on the edge and not all into the center. And you could do a couple little spots. Let it flow off. And this is really where you can get as creative as you want to be. So you can kind of see that. The slope of your volcano is going to affect how it moves. So we'll do that one. Add a little bit more eruption here. And then what we'll do is we'll just throw the next color on top. So we're going to have a little bit of a gradation in colors. Let that go a little bit longer. And so that way then, you can reuse the same material and keep going. So I'll bring this up a little bit. You can actually see the ponding happening. So those are kind of like little ropes that would happen. So there are two main names for lavas. There's Pahoehoe, which is Hawaiian in its name, and it has to do with the ropey nature of it. And it's actually named after when you have your canoe paddle going through the water and the swirls that happen afterwards. And the other type is called A'a, and that is after, because it's all this very viscous clinker, fragments of melted material, and it has to do with the eyes that you would see in the night. Like if you've seen a Disney movie and they're in the jungle and it's scary and all the eyes are showing, that's the A'a. All right, so we'll add the next eruption. We're going faster now. And there's still a little bit of yellow coming out, which is not a bad thing because that's probably more like nature. You never have all your eruption happening at once. And we can actually, put flows over the top of it. So we'll go for another color. We'll add some red. So now we're going to basically make we'll go with this purple. Basically make a brown lava flow. And so if I lift this up, we can start to see some different flow features. There's some ponding still. A couple little sections that look braided, so they went around some sort of an obstruction up high right through here. I'm trying not to let it drip all over the place, like onto my computer. And we can even see in this one, I'm trying to find, this one, you can actually see levees that form. So the edges cool more quickly and you'll have more flow through the center of the lava flow. And this is actually how lava tubes form, is you build up on the sides and then you start to insulate the flow. Does anybody have any questions so far? And maybe we'll just do 3 colors to move a little bit faster.
So Fred had a question. How do you simulate
So, oh, perfect question. So actually what I'm going to do is I have some shavings of paraffin wax from when I built my volcano, and we're just going to throw that in. And that's going to take longer to melt, and it's actually going to start to create little obstructions. You could do it with sand or something else. Maybe throw a little bit right there.
Move your camera down some too.
Oh, I'm so sorry. Thank you. I'm not as good as Rachel Ray. Let's try to melt that just a little bit more. So it wasn't as good. I need finer shavings. I should have done that a little bit better. Well, it was not as good. It did not infiltrate very well. But you can start to see kind of in through here, some of the flakes of the paraffin wax are sticking out, and it's creating a rougher surface texture. So that's one way to do it. The other way is you could use paraffin and throw the crayons in there. There could be a lot of ways to test that. The other thing is that you could, here, we'll do one more crayon now. So we'll put one last crayon in. We'll go for just a regular red. Is to have it melt and then let it sit and cool a little bit. That'll increase the viscosity. So we'll give that a moment. And maybe like wood shavings would be a better option than sand. Sand is probably going to be too heavy. Wood shavings could be a good idea.
It reminds me of how we used to decorate wine bottles back in the day with candles.
I don't think I can. It's like the Maker's Mark bottle or something. Okay, so we're fully liquid, and then we'll give it a minute and cool it down just a little bit so we can start to see it kind of sticking to the sides, and then we'll create a flow. And that way you can actually start to make like lava domes. You dump just a little bit, dump a little more, and you can start to build these things called lava domes, which are like Cerro del Medio from Sherry's presentation, where they're multiple little flow lobes that are happening in a fairly short amount of time. There's actually a master student right now at New Mexico Tech who's redating a lot of these eruptions at Fiesta. Give that just a little bit longer. So there's, turn this guy down again. We'll just pour slow and just see where it goes. Yeah, so we can do that. I've just built just a tiny little dome right there. We'll swirl it a little bit more as it's starting to lose more heat. Can make another little dome. It's still a little warm. Make a little spatter rampart, I guess. I don't know how easy it is to see a lot of this. Give that a second. So I'll stop there and I'll pull it up if it's easier to see. Might turn this. Okay, so you can start to see we're building a little bit of a dome here. I can't see my finger because it's almost flat. And then there's a lot of little textures that are happening at the top. So we're actually building it up more, and we're covering old lava flows, and we can just see some of the old edifice sticking out. But, you know, this is with 4 crayons. You could do 10 crayons and just continue to keep building and building and building this volcano until you know, have no clear Gulf wax left, or maybe just a little bit. You know, this little guy over here, oh, too far. So there's one little red guy over here. This could represent, you know, what they call a parasitic cone. So it's a cinder cone that erupts on the side of a volcano that really just doesn't go anywhere. You know, this lava flow, where am I at? There. Sometimes what can happen is you can actually have lava flows. If you have wet sediment, they can actually sink down into the sediment and come up someplace else. This happens in the Columbia River flood basalts in Washington and Oregon. So there's a lot of interesting interpretation that can start to come from this tiny little, I don't know, 15-minute volcano. And what we'll do is we'll let this cool down for a little bit, and then we'll cut it in half. I'll go get a hacksaw, and then we can actually look at the internal structure of this tiny little volcano. So then we can actually talk about what the stratigraphy looks like after multiple eruptions.
Actually, I'd say that the Mount Taylor
Okay.
cross-section would look more
And
analogous, and
in the
it's,
book.
I doubt that I can, no, I can't do this. Well, go ahead and cut your model and let me see what I can do.
So the Mount Taylor cross-section is from, oh, I don't have the reference, is in the book, right before the caldera box. And so when I was cutting it with a hacksaw, it broke in half. I didn't have a very stable volcano. Actually, this one's cleaner. So here's the interior of the volcano.
Nice.
And so we have different layers, lava flow, we'll call them series, going upwards. And so, you know, we can turn that around, and, you know, this is the oldest lava flow, green and red, and we can actually see that same thing. However, in this side of the volcano, we actually have no evidence of the purple unit. So if we go to the other side, I tried to clean it up a little bit better. The purple unit and the green unit are kind of smeared together, and there's a lot of red on top. And if we turn it around, you know, we see more purple, a lot of red, and less yellow. So you can, hopefully if your volcanoes are a little bit bigger than mine, they'll actually glue together better. But it's kind of interesting to be able to cut this thing in half and show the interior of the volcano itself. So then you can start to talk about stratigraphy, and, you know, we have our oldest stuff, at least in this case, on the bottom, and then working upwards. So you have some time information there too. And then also this really, you know, nice little ridge that formed when we were trying to make the there was just a bunch of clumps of white. So a little tumulus.
So here is a cross-section of Mount Taylor volcano. You can, I don't know if you can see it. And here, what the map looks like. You can see it has a lot of similarity to the top of Nels' model. So.
Beautiful map, Sherry.
Yeah. Nice.
So I don't know if you can see my screen, but that's a top-down view and a cross-section.
Looks good. That's a nice visual.
I should have brought the other one from home in my demoing time. That one looked really cool, and that's actually what's in your in the book. Is this one that I made at home during the early quarantine phase. So the nice thing is that, you know, we only did 4 colors. The more colors you put on there, the more complicated and cool it's going to look. So even if you get to the point where you're trying to maybe blend some colors, it'll be really nice. And the approach of, you know, there's a little bit of residual wax in there, and so it allows you to kind of get that gradational color for all the different lava flows that would actually turn out if we were, you know, mapping each of these individually. So